Or what do I have to do in general? What would be our first? Yes,
you have to make sure that. Go ahead.
So look at the function and say, I think we're going to do this first. And I'm pretty sure
we have to find the domain and what x can't be.
Excellent. In other words, factor. Oops. We always factor and find the domain. Awesome. What will you factor out from the numerator? I lost my props.
2x.
Of course. What I was going to say, don't look at the denominator. So in the numerator, we factor out 2x. Very good. What is left?
3x plus 2.
So it's 3x plus 2. Very good. Awesome. I completely agree. So 3x plus 2. Okay, perfect. What about the denominator?
Factor out x.
Yes, factor out x. And what is left?
3x minus 1.
3x minus 1. Perfect. Do not attempt to do anything before you state the restrictions. Do not touch anything. Okay, so what are the restrictions?
X, 1.
X.
Maybe you said it, but I couldn't see it.
X is different than 1.
Let's try. 1, 3 times 1 minus 1 is 2. 1 times 2, why?
Of course. 1/3.
Ah, brilliant. Indeed, 1/3. What else?
0.
Yes.
0.
Yes. Now I can clean it up. What will I clean up? What will I do? Can I simplify anything?
Can't you simplify the 2x and the x?
You mean the x from the top with the x from the denominator, which means because this factor went away, this is not a vertical asymptote, but a hole in the graph. However, x equals 1/3, because the factor stays, is a vertical asymptote. When a factor like that goes away, the function is still undefined, because we are talking about the original function. The original function is still undefined at 0, but that x equals 0 will not be a vertical asymptote, but a hole in the graph, something like this. So the simplified form of the function is f of x equals 2 3x plus 2 over 3x minus 1. Can I determine the point that is the hole? Yes. With x equals 0, plug in 0 in the simplified form. These two terms go away. So what is the y value of the hole? So it doesn't exist.
-4.
Yes, because exactly, -4. 2 times 2 is 4 divided by -1. Excellent. So this is the hole. Okay, perfect. But now we know that x equals 1/3 is a vertical asymptote, and I have to determine the limits. As x approaches 1/3 from the left of this, and limit as x approaches 1/3 from the right of this. Because it's a vertical asymptote, blindly, I don't need anyone to tell me the answer. But what I don't have is the sign in front. That's what I don't have. Once I know that this is a vertical asymptote, I know it has to be infinity because it's a pure rational function. But I don't know the sign. How do I determine the sign? Very easy. Imagine you plug in something to the left of 1 divided by 3. The numerator is positive. You shouldn't even worry about the numerator because with 1/3, the numerator will be what? 6, right? 3 times 1/3 is 1. 1 plus 2 is 3. 3 times 2 is 6. Positive. But I need to find the sign here in order to find the sign here. So let's plug in. So 1 divided by 3 is like 0.3. We only plug it in here. I wouldn't waste my time to plug it in the top, right? We already did that anyway. So let's plug into the 0.33 here. And 0.34 here, because I have to be on the other side. Or you can say, I can't do this in my head. Okay, that's fine. If you can do it in your head, that's fine too. I'm just going to punch in 3x, which I already know the answer, but okay, so let's punch in 3x minus 1 just to find the sign. And then to the left, point. So let me just do this. So 1 divided by 3, right? We know it's 0.33, but I don't want 0.33. I want to the left. So 0.329, let's say. Ah, it's negative. And on the other side, 0.34. Ah, it's positive. Done. So negative on the left, positive on the right. And that's it. Now I need to determine the horizontal asymptote. How do I do that? Well, I have to find the limit as x approaches infinity of this function, the simplified one, of course, and the limit as x approaches negative infinity from the simplified form. If I get a number, 2, 5, 10, negative 3, then I'll say that is the horizontal asymptote. If I get infinity, there is no horizontal asymptote. Good, so how do we do this? If you remember, we factor out the degree when we look at infinities because this is infinity over infinity. Same thing here. They will be the same, so I'm just going to do this one. So limit as x approaches negative infinity, we factor out the degree. Put the 2 in front, we don't care. It's a constant, it can go in front. So factor out x, and you tell me what to write in parentheses, and factor out x, and you'll tell me what to write in parentheses.
Three plus 2, so 5.
So careful. I do write 3, but I cannot write plus 2 here. X times 3 is 3x, but x times 2 is not 2.
Is it 2 over x?
Very good. Let's try again. Always remember, when we factor, take 5 seconds to check. X times 3, 3x. X over 1 times 2 over x. The x's go away, and I get 2. Check. What do we get in the denominator? So please remember, it takes 5 seconds to check all factorizations, so you don't make a mistake. So what do I write here?
Three, 1 over x.
Sign.
Minus.
Very good.
Sorry.
Let's take 2 seconds. X times 3. Check. X over 1 times 1 over x. Negative 1. Check. What is the next step? Look here and tell me what to do next. That was the purpose.
Yeah.
To get rid of this. Good. So now x approaches infinity or negative infinity. Where is this going? And where is this going?
Towards 0.
Very good, of course, because we divide $2 by a billion people. $1 by billion people. Of course, nothing. No one gets anything. So what is left and what is the limit? And don't forget the 2 in front. So first, what is this limit equal to? Forget about the 2 for a moment. What is this limit equal to?
1.
Exactly. Times?
2.
That's 2. So therefore, y equals 2 is the horizontal asymptote. A lot of work, right? A lot of work. First, we simplified the function by factoring. Then we wrote restrictions. Then we went back to fully simplify it. We realized that this is a vertical asymptote. I have to find limits left and right. I have to find limits left and right of x equals 1/3. And then I have to identify the fact that at 0 is an open point or a hole in the graph, not a vertical asymptote. Then I found the hole. I needed to graph whenever I get the chance to graph, when I'm asked to graph. Then for this, I have to find the limits left and right. Then I have to find the limits at infinity. Why? Because that's how I determine the horizontal asymptote, finding limits at infinity. So I determined, and this is also the same thing. Same thing, because this is a rational function. It's not a combination with natural log, with radical, with exponential. It's a pure log. It's a pure rational function. So these two will always be the same, these two limits. Then I had to factor out the degree, top and bottom. Then I had so on and so forth to determine the horizontal asymptote. A lot of steps. Okay.
So, Professor?
Yes, I'm here. Yes.
Sorry.
Go ahead.
Since you said they were always the same, if we were to do this on a test or
yes,
homework.
I'm happy. Yes. But remember, they're not the same if I have a situation like this. They may not be the same. My tests are not set for endurance, okay? So you're not going to get something like this, but I want to clarify. So if I have a situation with, let's say, x to the 6 plus 1 over x minus 3, this is not a pure rational function. Limits from at x approaches infinity or x approaches negative infinity may not be the same. So please remember that. This is not a rational function. It's a combination of rational with radical. So this one that we just looked at is a pure rational function, polynomial over a polynomial, which means on both sides they will always be the same. But here they may not.
Okay, so then if they are the same,
I'm fine. Absolutely. Absolutely.
One of them rather than both of them?
Yes.
Okay.
Yes, absolutely. You don't have to waste your time. Okay.
Okay.
So now let's choose a function and go through everything, including graphing. Now we are ready. One thing I was going to mention, what is the difference between type, we looked at type 1. What is the difference with type 2? Since the degree in the denominator is bigger than the numerator, everything is the same, except the horizontal asymptote will always be 0. Both ends. Because this is so much smaller than this. So at infinity, the horizontal asymptote will always be 0 for this. And this is a totally different situation. So I'm going to show an example like this. Okay, this one, we know how to determine the horizontal asymptote by factoring out the degree. Here, you don't have to do anything because the limit, when x approaches infinity, this is much smaller than this. So it's the same situation. Much smaller over much bigger, 0.
Is that what you want us to?
When you if you encounter type 2, so for example f of x equals x over x squared
I meant
minus 1.
like, is the last problem the one you want us to upload? Sorry, that's what I was.
Oh, yeah, just no, we want to start a problem. Just 1 minute.
No, no.
So
Okay.
so this, I'm okay if you write 0 already, because what happens is this is much smaller than this at infinity. At infinity. If the limit if x approaches 2, everything counts. You can't say it's 0, right? It's 2 over 3. 4 minus 1 is 3, 2 over 3. But when we talk about infinities for horizontal asymptotes, this is so much smaller than this. So therefore, eventually, this will be 0. So then y equals 0, horizontal asymptote for all type 2, forever. For all type 2, the horizontal asymptote is always y equals 0. Okay, so let's look at a situation. Okay, so let's look at problem. There is no easy problem in this book, so I may have to make up some. Okay, so let's say 43. So we have f of x equals x minus 3 divided by x squared minus 2x and minus 15. So they're asking us to sketch the graph of this function.